Hi, so in the last video we set up the part file for our op 20. This is going to be our second op, and in this video we went through how we set up all the geometry, we relinked all of the parts, we created this stock body that you can see here, and now in this video we're going to go through the complete second op. The second op is, for this part especially, is going to be quite an easy one. We only need to get rid of the top stock and the bird apart. Basically, there's not much else to it. It should be quite a simple video. Okay, so let's get into that. So I need to think about a strategy in terms of how I want to remove this material off the top. So I can see there's about a 5mm overhang here and here. So sometimes what you can get is when the more this tang starts to come out, it will change the way that you'd want to remove a resulting stock like this, because there's two ways to do it mainly. There's obviously other ways, but the main ways that I see this is you're either going to adaptive mill the whole thing until you come in to a pillar, or you're just going to like cavity mill or like face mill the top off basically. But sometimes this tang here can be annoying if you're just going to face mill the top off, because as you start to cut down here, so as you do like 2mm cut, 2mm cut, 2mm cut, you're going to get, this is going to be really thin and it starts to get flappy, and what happens is when your last cut comes to take it off, you get a bit of aluminium that can either wrap around the tool or it'll just fly off and hit the window. So that's a couple of things that you probably want to avoid there. So I'm going to take the safe route with this here. And what I'm going to do is I'm going to adaptive mill just around the outside to this sort of profile. I'm going to take the outside profile of the part and I'm going to adaptive mill to it. And that way it's going to ensure that we don't have any of this tang left, and it's just going to be a nice solid bit of material at the top. So let's go ahead and do that. So in my unused, I left the rest of the other program in there. So I've still got this 16mm toolpath in here, and that's going to be perfect for what we want to do here. So I'm just going to drag that actually and just put it into our op 20 program. And now I want to change my heights around a little bit. So my top level, it's picked it out for me by the looks of it, or close enough anyway. I'm just going to increase that a bit. Doesn't really matter, but we're going to be above the part. And then our floor, we want to be about there-ish. So there's two ways of doing this. So you can see here, I'm not completely, at the bottom of my part, somewhere around here, when you've got the chamfer there too. So if I just hide my stock for now, you can see I'm just above my part. So you'll see what happens here is all of our settings should be pretty good from before. Just quickly run through them. 0.5mm. What's good? 3D is on. Yeah, so let's just generate that and see what it gives me. So you can see here, this is one way to remove all the stock. And to be fair, this is probably a pretty good way to do the whole thing. You can see somewhere in here you'll see a time. So here in one of the columns I've got 20 seconds, which is pretty fast. It's not, you don't want to be going much faster than that, I guess, but this will just adaptive mill the whole thing off like so. Let's have a look. Okay, so that avoids this tang. That's one way. But what I really want to do is, and this is better if you have like one big face mill. So for example, if you had quite a lot of material to take off this top, let me check the width of this part. I'm going to go into the measure tool. I'm going to measure the width of this. So it's 50mm. So a 63 face mill 63mm wide face mill is quite a typical face mill, so that could be perfect for a job like this. The reason why this isn't an ideal toolpath, although it is fast, the problem with it is we are only utilizing, whatever this is, it's about 15% of the flute length. So what you're going to get on this tool is, if you had 100 of these to do, you're just going to get really uneven wear for this tool. So the end of it, the first 15mm might be cabbaged over the lifetime of like 100 parts or something, but then the rest of this flute length here is still going to be in really good condition. So you're not utilizing the cutter fully. So it's not ideal in that sense. So if I ever do stuff like this, what I like to do is, one way to do it would be, I could specify a trim boundary, and I could select this outside shape of the part, and the side trimmed, I could say the inside, to say I don't want to cut the inside, I want to trim out this inside, and you can go everywhere else. So now if we generate this toolpath, now you can see it's ignoring that inside part. The easiest way to do this would actually be just to forget this trim boundary. So we can go into the list and just remove it. And the easiest way to achieve this would be to go a little bit deeper on the depth here. So I'll just go -5. Because now that the tool is below this face here, this top face, it knows that it can't cut across there because I'm setting a level here. This is the easiest way to achieve it. Okay, so that's good. So now we've got rid of this little overhang here. So now if we verify, see what we get left with. Okay, so now we've got no overlap, no overhang, which means now we can get rid of this top face without any worries. So again, this face milling toolpath could be pretty good as well. This one here with a 16mm, because this is our roughing tool. I just noticed we've got no roughing folder in here, so actually let me just dump the roughing folder under there as well. And the two toolpaths that live inside there, I'll put back into unused. And then the two toolpaths that we've just done, I'll dump back under there. Okay. So you can see here again on this part that we've got, it's showing me the stock and the part all the time. I don't like that personally. So I'm just going to go into menu, preferences, manufacturing. And I'm going to turn off this display selected objects. So now when I press toolpaths, it doesn't show me all the things to do with that toolpath. So let's get rid of this top face. So roughly we know we have about 5mm of stock on there. So we need to set the cut area. So as it previously was the bottom face, we're now going to switch it to the top. I'm going to say the floor blank thickness, let's say 6mm. And we'll do that in 2mm depth of cuts. Something like that. And you can see it's projecting the levels for us here. So now I can actually just flick on the part. So I need to go a lot higher actually. So if we go 10mm. Okay, so 10mm's close, but you can see our first cut is actually above the stock. So that's just a waste, that's just a fresh air cut. So we'll go to 8 and now we can see our first cut is going to cut. That's perfect, that's what we want. So we should just be able to generate that toolpath now. So a couple of things I can see that we need to change here. We need to change the runoff. Because if we just verify that, I think we're going to be engaging onto material. Yeah, so there, that plunge down is actually onto the material, so we don't want that. So we need to extend the runoff. And we can do that by going into non-cutting. And we've got a linear here of 10%. Let's up that to 50% of the tool, or maybe a little bit more. Let's say 60% of the tool. Okay. So now I can see that should be clear. double check. Yep. Now we're coming off the part completely before so we don't want to have any of that engage coming down onto the part. It's not good. So I can see here, and it looks like it's leaving a good 0.5 mil on that top face for me. Okay, so looks like we're straight on to the finishing now, because this top face is the only roughing that we actually had to do. Just double check. Okay. So the next step that I'm going to do is I'm actually going to put the chamfer on. And the reason why I do the chamfer before this top face finishing is because, you know, through my experience, something that I've realized is you can finish this top face, and depending on how flat this needs to be or the tolerance on it, what can happen is you can finish this top face, and then when you come to put the chamfer on, it can actually throw a little deburr up on this edge here and this edge. So what I like to do is I like to leave this semi-finished. I'll come in, I'll put this chamfer on first, and then I'll skim this top face just to ensure that it is completely flat. So we can use the finishing folder again from here. And the only toolpaths that we're interested in here are this zigzag toolpath, because this is going to finish the top face for us. And this holes and chamfers. Let's drag the holes and chamfers down, and we'll do that first actually. We'll do that before the finishing. So we don't need the drilling, and we don't need the boring and reaming, and we don't need the deburring anymore. So I'm going to go ahead and delete these toolpaths now. I'm going to delete the ones that I've unused as well, because they're not going to be used either. So here I can see, you remember how in the previous video we used feature-based machining to put these chamfers on? We're going to do the same thing here. This is the beauty of feature-based machining, because now I can just come in here and it's already recognizing that chamfer for us. It already realizes that that's the top chamfer. So I should just be able to go ahead. I need to flick them around. So we want to do the bottom chamfer now. Interesting. So it is classified as a top chamfer. What's our direction? Can't see it. Seeing the diameter as 0. That's why it's not giving me a toolpath. Let's turn off all. Sometimes when you're not getting a toolpath, we can just turn off all the collisions just to try and force something. Still not getting anything. Okay, let's double check the geometry. Let's just try and select it outside of the group to begin with, just to see where the issue is coming from. And the issue is coming from the fact that it's not seeing it as a through hole. So if I just manually open this up, 4.2, will that help? Yeah. Okay. That's interesting. So let's put it back into the geometry group, so it's looking at that geometry group. And in here, I'm going to manually make sure it's got a diameter in there. So because it currently thinks that there's no hole there for some reason. Not entirely sure about that. But we're going to trick it and say that there is a diameter there. Because it says there's a diameter of 0, it doesn't understand how it can plunge into like stock basically. So by saying that there is actually a hole there of 4.2 diameter, which we know that it's there, it allows the tool to plunge inside, like so. So now those chamfers are back on, and we can update this planar mill toolpath. This is going to put the chamfer on around the outside of the part. So we're going to do curves, and the boundary type is going to be closed. We want the outside still. I can just go ahead and select this line here. And then let's double check where our floor is. So obviously that's not right. We're going to change it. So we click this top face, and it already remembers our 1 mil offset in there. So the tool tip is going to come straight down to this plane. Okay. The chamfer put on for us. So now the part is completely deburred again. Now we can go ahead and finish the top face. So I'm going to steal this toolpath here. And I don't need any others actually. Let's get rid of all of the other ones now. And this should be a really simple change. Just reselect this top face as our cut area. And I think it should just be a regenerate. Let's have a look. So we need to extend this runoff here and here again. So let's go ahead and do that. I'm going to extend it from 10% to 60%. The reason why it's 60% is because it's always half of the tool and then a tiny bit more. Like that. Okay. And that should be our op 20 done, just like that. So let's just run through what we did. So first of all, we got rid of the little overlap, the little overhang, sorry. Let's run through. So we get rid of this tang so it doesn't snap off or fall into the tool and potentially break it or go flying at the window and scare the operator. Then we remove the top face in very standard sort of face milling strategy. Then we go ahead and we do the little chamfers first before we finish this top face. And something that I've just noticed here is we're doing one big 0.5 finish on this top face, which is fine, but we want to achieve a nice surface finish on this top face. So we are going to add 2 passes. And one nice way that I like to do this is if you just say the floor bank thickness is 0.2, for example, and then in the depth per cut, I do 0.1. And what this does, it will do 2 0.1 finish cuts. So the first cut will be, it will take 0.4 of a mil, and then the second cut will be perfectly on the face. You can see here we've got 2 passes. So this is just going to be a semi-finished pass to 0.1. So that just ensures that your last pass is only 0.1 depth, which is going to give you the best surface finish possible. The last thing that we need to add is if we look at the drawing again. So let's get that open. You can see that we have this plus or minus 0.05 thickness tolerance. So we need to make sure we hit that. That is the last thing that we need to hit in terms of tolerances for this part. So we need to add another stop. So I'll give you a quick minute just to have a little think about how we are going to go around adding a stop. So when the machinist is running this, it's going to stop and it's going to prompt a little message for them to check a certain tolerance. So if you can remember, just have a quick minute to think about how we go about adding that to the toolpath. Okay, so if you remember rightly, we use end events. So when you right click the toolpath, you go to object, you have start events and end events. Start events are events that happen at the start of a toolpath, and end events are events that happen at the end of the toolpath. So in this case, we want to check at the end of the toolpath. So again, there's lots in here. We only want the stop UDE. We're going to add that event. We're going to put some text in there, and I'm going to put check 15 mil, or I'll do, this is what I would like to do most of the time, check 14.95, to 15.05 thickness. Just double check that I have actually got that right. So analysis, I'm going to check the thickness. 15 mil, yep. Okay. So now when we run through this part, we should be complete. Okay. That looks good. And there we have it. Our first part is complete now. Don't believe we missed anything. It looks pretty good. We don't have to worry about creating any stocks for this because this is our last operation, and this is the last operation for this complete part to be finished. So that this essentially is your first complete part programmed in NXCAM. So it's a massive achievement for you, and I'm glad that you've helped follow this course. There's, you know, we're going to get many more courses to come, many more lessons to come in this course in particular, because we have the next part to get into, and the next part's going to be exciting because it's our first challenge part. So it's going to be a part very similar to this one, but you're going to program it completely by yourself. And one thing that I am going to say, which could be quite fun, is once you've finished programming the part, don't look at any future lessons. Just have that part completely programmed and send it in to me. I want maybe send it me via Dropbox or any sort of file share system, because I'm going to do like a live stream on YouTube at some point, and then we'll get to run through all the people that have completed the parts. We'll get to run through them and judge them, and maybe we'll have some rewards that go out to some people. Maybe we'll give some stuff away, some merchandise or stuff like that. So yeah, it could be fun. Well, thank you for sticking around for this lesson, and I'll see you in the next one.